Good day. Today we're looking at law of sine. For law of sine, we are using an oblique triangle. That means I don't have a right angle. For an example, there is an oblique triangle. If a triangle ABC has sides of length A, B, and C. Now the way this is written out, the lowercase letters are the opposite sides from the angle. So here would be lowercase a, here is lowercase c, here is lowercase b. Then, sine of angle A divided by length A is equal to sine of angle B divided by length B, and the same is true for the c's. Now I do want to show you the reciprocal is also true. You don't have to write this if you don't want to. It is very handy to know. A, side A, divided by the sine of angle A is equal to side B over sine of angle B. And you can tack on C at the end. So you can use the reciprocals. It may make life easier for you if you realize that. Okay. You can read this when we can use law of sine. Let's get into the practice. Solve triangles ABC, round side lengths to the nearest tenth, and angle measures to the nearest degree. All right. For the first triangle, I'm going to look at angle C to begin with. Now I am going to rework this here in a minute and show you a law of sine way after we have another side to get this, but first, let's do it arithmetically. 180 degrees are the total degrees in a triangle. If I subtract the 35 degrees summed with the 103 degrees from the other two angles, that's 138, I can get 42 degrees as this missing angle. Now keep that in mind. Momentarily, I'll show you how to get 42 degrees using law of sines. To do that, since I don't have a side C, I would find side A first. So if I have A divided by, notice I'm using the reciprocal because it is easier. I'm looking for the side length. I'm starting with the side length as the numerator. Side A divided by sine of angle A, 35, is equal to side of B, 20, over sine of angle B, 103. Multiply both sides by sine of 35 to solve for A. A is equal to 20 times sine of 35 divided by sine 103. Okay, from here, I'm going to type this in Desmos. Again, make sure you're in degree mode. 20 sine 35 degrees divided by sine 103 degrees. 11.77. Now it says round to the nearest tenth. I'm actually rounding to the nearest hundredth here. I like giving a few more decimal places just to keep my numbers consistent. Okay. Now I'm going to solve for angle C using law of sine. Again, we found that arithmetically using the angles of the triangle. Please do that if it's your individual problem. It is much easier, it is much faster, but I still want to show you this as an example. So I'm looking for angle C. I'm going to use sine of angle C divided by the side C, which I have not found yet, so I should probably find that first. Here's a recommendation. You don't have to follow it, but my recommendation is if it gives you a set of numbers like this, I'm using that every time, even though I could use A and angle A. But I'm going to use my B's. Type this in Desmos as we did before. It is approximately 13.73. Okay, assuming I had given you that, you'd put in 13.73 as the denominator to find angle C. You're going to set this equal to either one of your two sides. Again, I'm using B because that's the one it gave me originally in the problem. Sine of 103 divided by 20. From here to solve for C, I would multiply by 13.7 and then do arc sine. So C is equal to the arc sine of 13.73 times sine of 103 divided by 20. .98, round that, it is 42 degrees. Okay, that was just to show you in case you needed to use it to solve for an angle. Now, go ahead and pause the video, try these bottom three problems, and now I'm going to show you the answers. Okay, that is all I have for you today. Have a great rest of your day.